Not me. All right, so let's talk about the degree first. Just by looking at a graph, how do you know if it's even or odd? There's a couple different ways you can kind of think about it. So how would you know a graph is even or odd? The power, the degree, Maya.
If it's going the same way, then it's even. If it's going like the end behaviors of units.
Exactly. So one way to decide if they're going the same way, both up, both down, even. Opposite ways, odd. Opposite, odd. Jacob, another way.
I also think of original symmetry, odd.
Yeah.
Origin, odd.
And even symmetry is
Y-axis.
y-axis. So that's the other way to decide if it's even or odd. So two ways. One with end behavior, and then two would be the type of symmetry it has. So because this end behavior, they both go the same way, I know it's even. But I also know it's even because it has y-axis symmetry. So odd, original symmetry, opposite. So they should do the opposite if it's odd. They do the same thing if it's even, or the y-axis splits it in half. So we know then that this graph is even because they both do the same thing. Is it even in a positive function or even in a negative function? Maggie? Yeah, why is it negative? Good. So because both of them are going down, the graph goes down, therefore it's negative. So I know my end result should have an even exponent. The largest power should be even. And it needs to have a negative in front. So those are two things that we can tell. What else do you need to write an equation of this polynomial? Rebecca, what else do you need?
The degree.
So we need the degree. How do you know what the degree is?
It's 4.
How's it for?
Looking at the x-intercept.
Yeah, looking at the x-intercept. So here's an x-intercept of -2. Here's an x-intercept of +2. And the x-intercept in the middle is 0. But right there's only 3. Rebecca, how'd you get 4?
It's a double root.
Why is it a double root?
It's going out.
Nice job. So that center point is a double root. That's what makes it an even function. So instead of going through it, it crosses through it for a single root. It goes one direction, curves the other direction for a double root. Kevin?
You also look at how many turns there are.
That would be another way. You could look at the number of turns. So if there are 3 turns, the power needs to be 1 more than that. So a turn is a max or a min. So it turns here, turns there. So 1 more than the number of terms would be the turns, would be the power as well. So now we know it has a power of 4. The sign needs to be negative. And Allie, what can you do with the zeros to get this to look like an equation? Yeah, turn them into factors. So a 0 is a factor. So I can take a 0, to write it as an equation, I can write it back into factored form. So pretty much the opposite of what we're doing. So x plus 2, x minus 2, and then this is a double root. Should have left myself more space here. And if it's a double root, how do you show it's a double root? Rebecca? Great. So you write it as x squared. Throw a little negative sign in the front, and now it's negative. Just like that. Throw a negative in front. Now you have a negative function. The last step to get this into that true polynomial form that we've seen, so think of every equation that we start with has all the powers descending in order. Kevin, what would you do to get this to have a standard form of a polynomial?
I factored x plus 2, x minus 4.
And when you multiply those together, you get
X squared minus 4.
x squared minus 4. And then if you distribute that negative x squared through, you end up with
Negative x to the 4th minus 4x squared.
so
Or
close.
plus.
Plus 4, that's right, x squared. So now I have a polynomial function in standard form. We would have then done the opposite. In section 2.2 and this section, we're starting with a function like this. We're finding the zeros of factoring. So now this is giving you a graph and asking you to do backwards. Questions? So looking at B, Emma, what would be the difference from A to B?
Is odd.
So odd, it has original symmetry, which means opposite quadrants. It's reflecting over the origin. And it does the opposite. The one side goes up or the other side goes down. And it's also not only odd, but positive or negative? Negative. So this is a negative graph. It starts on the left and moves downward. A positive graph starts on the left and moves upward. So negative graph, it's starting on the left and moving down. It's decreasing, descending the whole time. So it's odd and negative. Just using the x-intercepts, we have 1, 2, 3 x-intercepts. They're actually the same x-intercepts. So -2, +2, and 0. But the 0 is no longer a double root. You can see the difference between the two. A double root curves, a single root crosses through the graph. So Quinn, what do you have for your equation?
For my final one?
Give me the factored one and then you can give me the
Okay,
final
so I
one.
have negative x, then in parentheses x plus 2, and another set of parentheses x plus
Perfect. And then your final equation.
2 was negative x cubed plus 1.
Nice. Questions? So you can see the difference between even and odd by one little x-intercept changing from a single to a double root. Questions? So as I said, I want to look at 91 and 95. So please look at your 91 and 95. So 4 steps that we did in the 2 problems from the packet yesterday. Yes, you have to use a calculator, but no, that shouldn't be the only work you do. You're going to do some algebra to support why you're using the calculator, to kind of show why the calculator is giving you those specific values. The first thing, doing P over Q. We have a -6P, Q is 2, and if I take my P over Q values, you end up with 1, 2, 3, and 6. So from the calculator, you want to pick a number in the list. So get a number that's in the list. Can anybody tell me 1, 0 from the list? And -6. I think a lot of people had that as a starting 0, -6. So Maggie, what do you do with that 0 of -6? Right. So the algebra part is to take the 0 that you got from your calculator and use synthetic division. What should your remainder be, Maggie? A 0. And if it isn't, you probably made an algebraic mistake, because if the calculator is saying it's a 0, then either you plug the numbers into the calculator wrong, or you did algebraically a mental math error, which happens. And it drives you crazy, but it happens. So drop down the 2, multiply, and add. That's a positive. -24, 1, and then 6 and 0. So after you divide 1 time, what is the power of this polynomial that we have left? Yep. X to the 3rd, because it started with a 4, and I guess technically it's a y, but we'll say it's x cubed. And then it's x squared, and then this would be x, and that would be my number. Now, the problem with stopping here, when you have something that is 2x cubed minus 5x squared plus 4x minus 1, that's not really factorable. How we know how to factor basic grouping. So instead of trying to force it to factor, look back in that wonderful calculator of yours and get a second 0, because there's actually 4 of them. So if we get a second one from the calculator that's also in the list, I can try and divide another time. So does anybody have a second 0? Kevin?
1.
1. Now I'm going to be lazy. I'm usually not lazy, but I'm going to use my same numbers that I have here. Just put a 1 here, and we're going to continue to divide. So I know Jacob's saying, yeah, I'm doing this too. Forget about rewriting those numbers.
Yeah.
We're going to just use these same coefficients that I just got from my answer. Remember, this is successive synthetic division. The goal is to break the problem down. So now I have a 1. I'm bringing my 2 down. and multiplying and adding. And I should get a remainder of 0 because I found it from the calculator. So I've done it twice. Katie, the power of this leftover, 2, -3, and 1 would be, so it would be a power of 2. So my resulting remaining equation is 2x squared minus 3x plus 1. How many zeros should we have? 4. I found 2 with the calculator. How can you find the other 2 with this resulting equation, Odette? Factor. So again, algebraically, we got a 2, -2, and -1 add together to be -3. AC grouping. Pull out what they have in common. And then I have a 2x minus 1, and then we have an x minus 1. That's done all algebraically with a tiny little help from a calculator. Just a tiny bit. Tiny bit. The question said to factor it completely. So it looks like this is pretty neat, I'd say. It's not too sloppy. So if I factor it completely, that means I want to list all of the factors that we have. I have 2 factors that I found at the end. So we have a 2x minus 1 and the x minus 1. And we got those after we did the synthetic division by finally factoring it. But we also have 2 other factors because I found that this was a 0. And we just said in that problem that we did, a 0 can be written as a factor. So if my 0 was -6, a factor would be x plus 6. And then I have another 0 here as a 1, so that factor would be x minus 1.
So could you just write like x minus 1 squared?
Yeah, so if you notice, you have a -1 and a -1. What's that called?
Double root.
A double root. So 2x minus 1. X minus 1 is a double root, and then we have x plus 6. So if you have a repeated factor, that's a double root in your graph. So in the graph, it should curve there instead of crossing through. If we were asked to list the intercepts, I would say 1/2. 1 is a double root, and -6.
I use the bathroom.
Sure. You will have a problem on your test similar to this problem. And I want to say it's worth like 9 points. Because it's a lot of work. And if you only have calculator answer, you're going to get 1 point. You're going to miss 8. So you don't want to have just a calculator answer. Make sure you have the algebraic work. Did anybody start with a different 0? Everybody, yeah, Kevin, Katie, did you still end up with the same answer? So just because you don't start with -6 doesn't mean you're not going to get the same final result. I think people started with -6, other people started with a +1. But start with a number in the list. That's the whole rational 0 part. Starting with a number from the list. Questions? Big problem, lots of work. Worth like 8 or 9 points. So if you look at 95, the last problem, before you think about trying to do the rational 0 test, sometimes the stuff that you learned originally gets forgotten about. And that's just going to happen because you're doing all these complex things and the basic stuff gets overlooked. What is one thing you could do, Taylor, with this function? We could take out an x, which is a really great thing because it reduces your power immediately. So if you factor an x out, then this polynomial has 1 less power, which means I have to do synthetic division 1 less time, which means less work. So by factoring an x out, I immediately know that I have an x at 0. So one answer, one x-intercept, is an x equals 0, just by factoring that out. Do you still have to look up another one in your calculator?
Yeah.
Yes. You can plug the original one in, or you can plug this new one in, because you pulled the x out. It's still going to have the same zeros, it's just you've got less to work with. Does anybody know what another zero was from this problem? 8? A negative, you said 3? So another 0 from the list would be negative 3. And then you're going to use synthetic division, just like we did with the last problem. But I'm going to use 8, 2, 9, and negative 9. So I'm still using that 8 because that 8 is still part of my coefficients. 28. Thanks. I missed my 8 there. Thank you. So synthetic division, bringing down the 8, negative 24, 12, negative 3, positive 9, 0. But if you notice that an x can be factored out, synthetic division one time, because my result says 8x squared, 4x minus 3. So your goal is to get to something that's x squared. That's the goal. Because then I can factor, or if I try to factor, and I can't, oh no. Your worst nightmare come true. Oh, this word. Gotta use that stinking quadratic formula. Out.
Should you always do a second synthetic division
If
it's
it's-
not x squared?
Yes, exactly. Yes. So if you end up with something that still isn't x squared, do a second synthetic division. Jacob.
Couldn't you always use the quadratic formula though? Like when it's just
Yes, you can always use the quadratic formula. As long as it's x squared, you
So
can
both
always
of
use
those
it.
would be right.
Say it again.
Oh, never mind. I was thinking like that.
she's kind of crazy.
You can also use completing the square. Like some people prefer completing the square. You can complete the square with that too. The quadratic formula, negative b plus or minus b squared 4ac
C.
2a. And then using your wonderful mental math skills, 16, 32 times negative 3, that's
Negative
90, 96 with the negative. So 16 and 96, 112? Now, how would you break down 112? Don't do anything yet with the 16 on the bottom. You gotta break down 112. I need two numbers that divide into 112. One is a perfect square. Mackenzie. 16 and 7. So, negative 4 plus or minus the square root of 16 is 4. And then we have 16 on the bottom. Oops. Jacob.
So I know you're gonna have to like cancel out one of the fours with the 16, but why can't you cancel out both of them?
You do cancel out both. Because what you do to one, you gotta do to every piece that's involved in the problem. So if you have a 4, and a 16, they're all divisible by 4. So you can't just divide one piece, you gotta divide all of them. So really, this is saying we have negative 4 over 16. I have a plus or minus, and then I have a 4 over 16. When a fraction has two pieces on the top over 16, really that means both parts are still over 16 separately. That's what that actually means. So that's why everything has to be divided. So Jacob, negative 4 divided by 4 is?
Negative 1, 4.
Yeah. And then this guy,
Be negative 1 or square root of 7.
and
16,
still over 4.
Oops.
So you could have it written like this as well if you wanted to. But make sure you're doing everything is being reduced. And you don't reduce until the very end. So you have to worry about the radical first, the square root first. So that's like a wonderful involved problem. Making sure you're using all of those skills that you would have discussed last year and that we've looked at so far this year. We've done a lot.
Yeah.
8 weeks. We've done a ton of work in 8 weeks. just in this chapter alone, which has only been like 2.5 weeks, we've done a lot in chapter 2. A lot of new stuff in chapter 2.
It's only 2.3.
I know, right? Like this is only 2.3.
Oh my gosh, that's crazy. Yeah.
So, getting to think back to the beginning of chapter 2, which was, I think, on the 26th of September when we started it. Remember we did completing a square and we did quadratic equations. We found the max and the min by completing a square. We found the vertex, we found the y-intercepts, the x-intercepts. And then last week in 2.2, we factored polynomials that could be factored with greatest common factor, with AC grouping with perfect squares. And then we've been working on the long division, synthetic division, and the rational zero test. That's a lot for one test. So in your packet, you already started one of the worksheets in there last night, and that was section 2.3. And I just want you to look at that because I want to make sure that you're understanding the directions so that when you see a question on Friday, you understand what the question is asking for. The first 5 questions on section 2.3 were pretty much just synthetic division and long division. None of them were the rational zero test. So use long division, use synthetic division to factor. After you're done using synthetic division, make sure you keep factoring. But looking down at number 6, the directions say to simplify. How would you simplify that? Dividing it. And how can you divide it? Long division. So long division is really a way of simplifying. So write yourself a little note, maybe like you're going to use long division there. Number 7, you're just listing P over Q. That's it. You're not doing anything else with number 7. So the possible zeros are just P over Q. And then when you flip it to the back, if you look at number 8, it says find all the rational zeros. Before you go crazy with synthetic division and P over Q, think back to the old stuff we did. What do you notice about number 8? Yeah, you can factor out an x. And then after you do that, a 2x. It's actually factorable after you factor a 2x out. So the easy stuff gets forgotten about once you start learning the hard stuff. The last 4 problems are all asking pretty much for the same thing. Find all the zeros, find the rational zeros. That's the whole problem like this. Do P over Q. Find 1 0 from the calculator, use synthetic division. It's not going to say to use synthetic division. So it's just going to say find all the real zeros. But if anything relies on the calculator, you've got to have that supporting questions. The other part of your homework is just for you to begin the review worksheet on page 33. Just the 5 problems. There are answer keys to both worksheets in your packet. So if you just flip, you'll see the answer key to worksheet 2.3. And then you flip a couple more pages and the answer key to the review is in there as well. Tomorrow we're spending the entire period just reviewing. So use the next, you got like 7 minutes left. See if you can start something. How many questions tomorrow? Like what questions do you have? Write them down so if we're not doing any notes, I might just have a little review problem for us to start the class so that we're reviewing for your test. Correct. So then this factor.
I'm not gonna lie, long division is still kind of stupid.
Yes. Yep. So factor. So it says factor. You don't get a remainder in your calculus.
Yeah. It triggers me.
What?
Instead of writing all there, just write -4.
No, but like
Yeah.
I'm sorry.
Yeah.
sometimes percent of every
Yeah.
That's it.
That's it.
Allie, I saw your hand.
Yeah, that's it.